Let me share my book now. Okay, guys, so these are the things we did last time. So last time we went over the binomial distribution because we are working with the discrete probability distribution. So first of all, we saw the binomial distribution, its properties, mainly the events are independent, means the replacement is there. And then after we went over the hypergeometric distribution where replacement is not required. I mean to say it's a dependent event, but when your small n is extremely less than this capital N, I mean to say the ratio of small n divided by capital N is less than or equal to 0.05. In that case, binomial distribution is approximating the hypergeometric distribution. So that is, we consider as the relationship between the binomial and the hypergeometric distribution. And then after I told you how to use the hypergeometric, I mean to say how to use the binomial distribution using the table. And I told you that last, I gave you the number also. I think it was around page number, I'm not sure what the page number I gave it to you, but I thought it was around 730, or let me just double check. It is 726 to almost 726 to 735, something like that. These are the pages from the back of the book on which the tables are provided to you, and you have to take the printout of these tables. I told you that take two printouts. One is in your room in bag, and one is in your bag. So whenever you come to the class at that time, we can use this one. And at the time of the exam, suppose you don't have that one with you at that time, you can use the second copy, which is already there in your room. So please do this thing just to avoid any kind of confusion or like this at the time of the exam, because some Poisson distribution we are going to see, and there is another table that is called table A2 for the Poisson distribution. Okay, few of the examples we went over here last time, example 5.31, 5.33, some of the examples we did from here. And today we are going to see the negative binomial and the geometric distribution, negative binomial and geometric distribution. Okay, guys, so now please pay attention over here. First of all, let's just try to go through this first part. Look at over here, this one. Very slowly I'm going to read this thing because that will give you the idea why the negative binomial distribution is required. Geometric distribution, I would say that is just a particular case of the negative binomial distribution. In negative binomial distribution, if you take your k is nothing but the successes, kth success occurs when k is equal to 1 at that time. That binomial distribution is converted in terms of the geometric distribution. We will learn all these things in next 10-15 minutes. So let us consider an experiment where the properties are the same as those listed for a binomial experiment, with the exceptions that the trials will be repeated until a fixed number of successes occurs. This is more important. Just look at this one. Fixed number of successes occurs whenever you are looking for not some fixed number of successes at that time. Usually we go for the negative binomial distribution. So fixed number of successes occur. Therefore, instead of the probability of x successes in n trials, of course, n is fixed. Now we are interested in the probability that the kth success occurs on the xth trial. So not x successes from total number of samples. Total number of samples that is equal to n. Total number of population is capital N. Total number of success is small n. Out of this total number of trials are small n. Out of this total number of trials, suppose we have x successes, in that case, we can go for the binomial distribution. But suppose we are particularly looking for the kth success from these xth trials, right? This x number of successes, and out of this x number of successes, we are looking for some particular number of successes, or 5 successes, 10 successes, something like that. We will see that example and you will have little better idea about this thing. So out of this x number of successes, some particular number of success we are looking for at that time, we are going to use the negative binomial distribution. I repeat, whenever you have total number of successes x out of n trials, small n trials from the total population of capital N, and out of these x successes, suppose you are looking for some particular, suppose you have 1 to 10 successes. Out of this 1 to 10, suppose you're looking for 7th success. means k equal to 7. At that time, we are using the negative binomial distribution. The definition for negative binomial distribution, before that, I just would like to give you this thing. The negative binomials or number capital X usually you know this thing that is denoted for the random variables, right? So capital X, that is nothing but the random variable. So number of X of trials required to produce small k successes in a negative binomial experiment is called the negative binomial random variable. I would suggest you to look at this one. Just this is how to generate the formula. That is fine. That's not that important. Main thing is over here. Just look at this last line. Look at my cursor. The number X of trials required to produce k successes in a negative binomial experiment is called the negative binomial random variable. Is called the negative binomial random variable, and its probability that is called the negative binomial distribution. So capital X random variable, and that's why it is called this random variable related to your kth successes, and that's why it is negative binomial random variable. Negative binomial random variable, and the probability associated with this one that is called the negative binomial distribution. Negative binomial distribution. The definition for this one that is given something like this. Just give me a minute. So definition of this one, that is, let me give it to you. That is the definition. Look at here. A negative binomial distribution, if a repeated independent trials can result in a success with probability P and a failure, you know that P plus Q is equal to 1. So Q is always 1 minus P. So Q is considered as a failure because maximum probability is 1. Out of this maximum probability 1, if you subtract the possible probability, that means that will give this case of failure. So repeated independent trials. Why repeated independent trials? Look at over here, repeated independent trials, because that is basically a binomial distribution. So repeated independent trials can result in a success with the probability small p and a failure of the probability q. Then the probability distribution of the random variable x, the number of trials on which the kth success occur, that is given by B star. Whenever B star is there, please keep in mind this thing that we are talking about the negative binomial distribution. That is B star, negative binomial distribution. B star, X, K, and P. Now you can see over here, we are talking about B star, X, K, and P. In binomial distribution, we talk about the, I mean to say that, in binomial distribution, we talk about X, N, and P. B of X was there, then N was the total number of trials, and P is the probability, right? That was N CX, P to the power X, Q to the power N minus X. That was binomial distribution. Difference over here for negative binomial distribution is X remains the same. Where is it? X remains, here. X remains the same. Instead of N, I have K, because we are looking for particularly kth success, right? And the probability. And the definition is given something like this, that is equal to X minus 1, Ck minus 1, P to the power K, and Q to the power X minus K. It's not now N minus X, it's X minus K. In binomial distribution, we were looking for the X number of successes out of N trials. Here we are looking for K successes out of X successes. Number of successes, out of that, we are looking for just K, some particular success. And that's why it is P to the power K and Q to the power X minus K, where K runs from, look at over here, suppose K equal to 5, 6, 7, something like that, some number of success. It could be possible K equal to suppose 0, 1. So then after 0, 1, 2 like this, but some particular success, that means you can start with suppose fifth success, fifth onwards, so 5th, 6th, 7th like this. But that's why in previous case, in binomial distribution, it was 0, 1 to X started with 0, then 1, then 2, then 3, and so on. Here, we are starting with K plus 1, and that's the reason the name of the distribution is given as the negative binomial distribution. That is the reason. Okay, guys. Now, I just don't want you to look at the solution. I just want you to read the example, and we will solve this example in our whiteboard. So, example 5.14. Example 5.14. One more thing, guys. I don't think that we have the what we say. table for the negative binomial distribution. We do have a table for the binomial distribution, but not for the negative binomial distribution. So please keep this thing in mind. Why not? That also I will let you know, because I think we are looking for just one kth trial, kth success, and that's why we can calculate that portion very easily. That's the reason, might be. Okay, so let me go for this one and let's read the example first. In an NBA, National Basketball Association Championship Series, the team that wins 4 games out of 7 is the winner. 4 out of 7. 7 games are being played. Out of these 7 games, 4, the team who is winning, not first, just 4 games. It could be possible that suppose A team, team A or team B or team C, what it may be. Here it is A and B. Suppose one team, suppose A, is winning first 4 games, and he is declared as a winner, right? Or it could be possible that A is winning, or A has won first and second, losing third one, fourth one, and fifth. Again, A won the 5th one, and 6th is missing. I mean, a loser is losing the 6th one, and again 7th is A won the 7th one. So out of 7, 4 games are won by team A. That means that is the another possibility, right? Another possibility. It could be possible that team A is losing first 3 games and team A is winning last 4 games. It could be possible, right? So some possibilities are there. Again, I repeat, in the National Basketball Association Championship Series, the team that wins 4 games out of 7 is the winner. Condition. Okay. Suppose that teams A and B face each other in the championship games, and that team A has probability. A has the winning probability 0.55 over B, because two teams are there. Once A is winning the game, that means the rate of success is getting higher than B. So that's why it is given very specifically. The sentence is mentioned here that A has probability 0.55 of winning a game over B. Okay, fine. So A is little bit stronger than team B. That's fine. What is the probability that team A will win the series in 6 games? Look at over here. What is the probability that team A will win the series in 6 games? So that means team A is not going to play, or team A and B, they are not going to play all 7 games, because out of the 6 games, team A is winning 4 games. Again, it could be first 4 games, or first 2 missing and last 4 games, or first is missing, second is missing, and first is missing, and then 3 games is won, and then after again 1 is missing and 1 is won by team A, like this. It could be any order. Order is not there. It's not, we are not talking about that thing. Not order is not important here. Only thing is team A has to win 4 games out of 6 here, because the question demands 6 games, not 7. Okay. Second part is, what is the probability that team A will win the series? Okay. Again, the same kind of question, but now we have 7, because now there is no restriction of 6 games or like this. If teams A and B were facing each other in a regional playoff series, what is decided by winning 3 out of 5 games? 3 out of 5 games. Look at over here. Out of 5 games, 3 games. Okay. What is the probability that team A would win the series? Team A would win the series. So these are 3 questions. Read the question twice. Then after, I would like to share my whiteboard. What is the probability that team A will win the series in 6 games? Okay. Means B star. If you consider the definition, B star is there. My X, 6 games, right? So X is equal to 6. My K, out of the 6 games, how many games team A has to win to be declared as winner? 4 games. So my Kth success, that is success rate, is 4, and probability is given to us 0.55. Just plug the values and I will let you know how to calculate this one. That's fine. That's fine. Okay. Second part, what is the probability that team A will win the series, right? Team A will win the series. That means, as I told you, that it could be possible that team A is winning first 4 games out of 7, or 5 games, right? First 4 games, or 5 games. Out of 5 games, 4 is won by team A, and 4 games are won by team A, and 1 is missing, 1 is losing. Team A is losing the 1 out of 5, or it could be possible that out of 6 games, team A wins 4 games, or it could be possible out of 7 games, team A wins 4 games. So because there is no restrictions, we can go for this one like this. Okay, and see, part C says that if team A and B were facing each other in regional playoff series, what is decided by winning 3 out of 5 games? 3 out of 5 games, that means here you have to be little careful. 3 out of 5 games, that means it could be possible. See here, now the winning criteria is 3 games out of 5 games, not 7 games, or not 6 out of 4, not 7 out of 4 out of 7, or not 4 out of 6. Is now 3 out of 5, right? So we can start like this: B star X is equal to 3, K is equal to 3, and winning criteria, winning probability is 0.55. Or X is equal to 4, winning number is fixed, K is fixed, so 3 is 1, that may, and P is 0.55, plus K, X equal to 5, because X is now number of trials, right? X is number of successes. Out of this number of successes, we are fixing K, 3 games. So number of successes. So 3 games are win, and all 3 games are 1 success rate, and all 3 games are won by team A. 4 games are won, and out of these 4 games, or 4 games are being played, out of these 4 games, 3 games are won by team A. Or 5 games, out of these 5 games, 3 games are won by team A, like this. And that is the answer of the third part. Now let me, so these are 3 questions. Let me share my whiteboard so that you will have a better idea about these A, B, and C questions. I will read the questions again for you when I'm A, B, and C part separately when I'll be solving the examples. Okay, so let me share my whiteboard, guys. Good. So first of all, it says that team A, what is the probability that team A will win the series of 6 games? Okay, so let me write, this is my question, or I would say example number, not question, but let me write example number 5.14, and let me write my definition for the negative binomial distribution B star X semicolon small k and probability P, that is equal to X minus 1 C K minus 1, K minus 1, and P to the power K, and Q to the power X minus K. And as I told you that X is nothing but K, K plus 1, K plus 2, dot, 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 so on. And P plus Q is equal to 1. So naturally, Q is nothing but 1 minus P. So these are the things we have to keep in mind. And this is my negative binomial distribution. Negative binomial distribution, right, guys? Now let me go for this example, and it says that A part is, what is the probability that team A will win the series in 6 games? So let me write B star, now 6 games, right? So 6 games, that means success, number of success, 6 games, and here we can say kth success. So what is the probability that team A will win the series in 6 games, not 7 games? Number of success, that is 4. That means team has to win, team A has to win 4 games. So 6, 4, and then probability is given to you 0.55, plug the values. So here it is, this is my X is equal to 6 minus 1, and K is equal to 4 minus 1, C1, and P, that is equal to 0.55 to the power K, already denoted to you. K is nothing but, yes, please help me. K is equal to, what is my K? K is equal to 4, and naturally K equal to 4. Yes, K is equal to 4. Q is nothing but, now P is equal to 1.55. 0.55. So naturally Q is equal to 0.46. So here I can write 0.46 and to the power x, x is equal to 6. 6 minus k is equal to 4. So 6 minus 4. You can write like this. So that is equal to 6 minus 1, that is equal to 5, and here it is 3. So 5C3. Here it is 0.55 to the power 4, and here it is 0.46 to the power 2. Here it is 5C3 means it is 5. NCR, again, we are using the combination formula that is equal to n factorial over n minus r factorial times r factorial. 5 factorial 5 minus 3, that is equal to 2 factorial times 3 factorial. And this will be as it is. And that is equal to 5 factorial can be written as 5 into 4 into 3 factorial divided by, this is 3 factorial and 2. This 3 factorial will get cancelled out. 2 factorial is 2, and here it is 2. So it is 5 2s are 10. So this is 10. Multiply, this is the same thing, 10 multiplied by 0.55 to the power 4 and 0.46 to the power 2, and use your calculator. Whatever the number you are getting, that must be your probability. Because it is a binomial distribution, is a probability, and that's why you must get the answer between 0 and 1. It should not be less than 0, it should not be greater than 1. You are going to get something between 0 and 1, right? It will not be exactly equal to 1 also, because probability of winning A, that is 0.55. So it has to be less than 1. So you're going to get some probabilities over here. Okay, now let me go for my B part. My B part says that this is just A part, right? This is A part. B part says that what is the probability that team A will win the series? Team A will win the series. See, probability of A will win the series. That means team A is winning 4 out of 7, right? 4 out of 7. That means I can start like this. B star, my x is equal to 4. My x is equal to 4, and all these 4 games, K is equal to 4. That is the success rate. K equal to, I mean to say K success. All 4 games are won by team A, and the probability is 0.55. Plus, it could be possible out of 7 games, suppose team A is losing 1 game. So 5 games are being played, and out of these 4 games are won by team A, and probability is 0.55. It could be possible that 6, and out of 6 games, 2 games are lost by team A, and they are winning 4 games, 0.55. 0.55. Plus, it could be possible that B star, and here it is, sorry, my bad, 7, semicolon, again 4 and 0.55. And close the bracket, right? 0.55. And same way you can find whatever I did over here, you can find the same way over here. I don't want to go through all these things, but exactly the same thing. Look at over here, 6 minus 1 and 4 minus 1. So here 4 minus 1 is 3 and 4 minus 1 is 3. And here it is 0.55, 0.55 to the power 4. So naturally 0.46 to the power 2, to the power 2. Right, guys? 0.46. So just 1 minute, guys. No. This is K and X minus K. X is equal to 4, right? And 4 minus K, that is equal to, here it is 0. Here it is 0 means no need to write. This is simply 1. 3 is simply 1, means you are going to get that is equal to 0.55 to the power 4. I told you, see, sometimes the calculations are really very easy. This is for the first part. Same way you can find the second part. So second part is equal to 5. Here, this is my X, and this is my K, and this is my P. So naturally X minus 1, that is equal to 4. K minus 1, that is equal to 3. And here it is P equal to 0.55. And K is nothing but 4. K is nothing but 4 and 0.46. And here it is X minus K, that is equal to 7 minus 4, that is equal to 3. Am I right, guys? 7 minus, why 7? I'm working over here, right? So 5 minus 4, my bad. So that is equal to 1. So 5 minus 4, that is equal to 1, right? 4C3, that is again 4. So you can write simply that is equal to 4 and 0.55 to the power 4 and 0.46, simple multiplication. Same way you can try this one and this one. So plus this one, and whatever the number you are getting, that is your answer. That is your answer. Now let's go for part C. So part C says that if Team A and B are facing each other in a regional playoff series, which is decided by winning 3 out of 5 games. Now, 3 out of 5 games, that means probability B star, that is equal to 3. What is the criteria? This meeting will end in 10 minutes. Upgrade now to remove 40 minutes time limit. Oh my gosh. Guys, I'm getting some message. Meeting is running out of time. This meeting will end in, I don't know why we have this criteria. I will send you the link again if that is a criteria. If we are disconnected, I will send you the link again. Please keep watch your email, guys, please. Okay, let me just continue for this 10 minutes, then after we'll decide. Okay, so B star, and here we have, where I was, yes. Oops. Yeah, so B star, and here it is 3, and then after 3, it says that Team A and B were facing each other in regional playoff series, which is decided by winning 3 out of 5 games. 3 out of 5 games, so first 3 games, and 3 games is won by Team A, and the probability is 0.55. Plus, it could be possible that out of 5, so 4 games are being played, and 3 games are won by Team A with probability 55, or 5 games. So I have to stop over here. 5 and 3 games are won by, again, exactly same thing that you can write 3C3. So X is equal to 3. So here it is 3 minus 1 is equal to 2, and K minus, so 3 KC X minus 1 C K minus 1, and P is equal to 0.55. 0.55 to the power K is 3, and and 0.44, and this is 3 minus 3. 3 minus 3, that is equal to 0. No need to write 2C2, that is simply 1, so it is 0.55 to the power 3. Plus, same way you can write 4C, 4 minus 1, that is equal to 3, and 3 minus 1, that is equal to 2, and 0.55 to the power K is equal to, again, 3, and 0.55, that is equal to X minus K, that is equal to 4 minus K, that is equal to 1. 3C2, that is equal to 3, right? Because 3 factorial, 3 minus 2 equal to 1 factorial, that is just 1, and 2 factorial will get cancelled out, is simply 3, and here it is 0.55 cube and 0.44. 0.44. Plus, same way you can go for the last part. Last part is equal to, here it is X minus 1, that is equal to 4, 5 minus 1, 3 minus, that is equal to 2, probability 0.55, and Q, and 0.44, and here it is 5 minus 3, that is equal to 2. So that is equal to 4C2. So 2 factorial, 4 factorial divided by 4 minus 2, that is equal to 2 factorial. And 2 factorial, right? So it is 4 into 3, 2 factorial will get cancelled out, and 2, so that is equal to, so it is 6. So here you are going to get 6 and 0.55 cube and 0.44 and square. Use your calculator, whatever you're getting, that is the answer. So this way you can go for, let me just save this one in a folder. Okay. And you can see over here, if you want, you can take the picture of this one. Otherwise, let me just go for the next example. So next example that is given, the negative binomial distribution derives its name from the fact that each term in the expansion p to the power k and 1 minus q to the power negative k corresponds to the values b star xkp. And x runs from k, k plus 1, k plus 2, and so on. That's the reason why we give the name negative distribution. But the main thing is, we have probability distribution for the number of trials required for a single success. Whenever this k is equal to 1, number of trial now required just for single success. An example would be the tossing a coin until head comes. So you can toss the coin. It could be possible that you are tossing the coin for 10 times and every time you are getting tail, and 10th time you are getting tail. So that is just one success, that you have to toss the coin until you are getting the head, right? It could be possible that you are getting head just in one trial or 2 trials or 3 trials or 100 trials. Just do it. Of course, the probability is very less, but just if you toss the coin and probability of getting the head, once head comes, you have to stop. So that means rate of success k equal to 1. Whenever this type of situation is there, in that case, I'm going to write my definition in the form like this. Look at over here, b star, and here it is x, and my k is now fixed because once head comes, you have to stop. So that is x is equal to 1 and p. So whenever we have, this is the particular case of negative binomial distribution, and this is called geometric distribution. I'm going to write this thing in the next slide. So let me close this one. Let me save this one and let me clear the drawings. And now let's go for the next one. So whenever we have b star of x and k and p, but when k is equal to 1, in that case, we are going to get b star and x and 1 and p, and x and 1 and p. What was the definition? The definition was something like this. Look at over here. The previous definition for this one, that was x minus 1 and k minus 1 and p to the power k and q to the power x minus k. And here I'm going to write that is equal to, because k is equal to 1, so I'm going to write p is equal to 1 and q is equal to q to the power k is equal to 1. So x minus 1, x minus 1. K is equal to 1, 1 minus 1 is equal to 0. So this is, here it is 0 and here it is x minus 1. And that's why, because we don't write this x minus 1, because now your x will start from 0, sorry, not 0. 1, 2, 3, and so on. You know that whenever the geometric series is there, geometric distribution is there, that always starts with this one. So 1, 2, 3 like this. So we don't write these things. So this is, don't write this thing, just p to the power 1 and q to the power x minus 1. And this type of distribution that is called, this distribution that is called the geometric distribution, G-E-O-M-E, geometric distribution. And people denote the same geometry because the geometric G is there, so people denote the same thing as x and p. Because k is equal to 1, when you write G, that means it is to be understood that your k is equal to 1. We have k is equal to 1. So people denote the same thing, gxp. The geometric distribution is being expressed in this form also. Gxp is equal to p to the power 1 and q to the power x minus 1, or pq to the power x minus 1, where x is equal to 1, 2, dot, 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 and so on. I can give you the example for a certain manufacturing process, geometric distribution example. So for a certain manufacturing process, it is known that on the average, one in every 100 items is defective. See, 1 in every 100 items is defective. 1 in every 100 items is defective. Means my k is equal to just 1, right? Kth success we are looking for. What is the probability that the fifth? Oh, okay. What is the probability that fifth item inspected in the first defective item found? So if you take the fifth item and inspect that inspected item, fifth item, that is your first defective item. I mean to say that fifth item defective, let me write it down. What is the probability that fifth item inspected is the first defective item? Okay, fifth item inspected is the first defective item. What is the probability? What is the probability that the fifth item inspected is the first defective item? That means my x is equal to 5. You can see over here, my x is equal to 5. And my probability is 1 out of 100. That is equal to 0.01. Am I right? Because first in 100 items that is defective. That is my probability. So my geometric distribution with x is equal to 5 and probability is 0.01, that is equal to p. P is equal to 0.01 to the power 1 and q is equal to 0.99, because p plus q is equal to 1 and q is equal to 1 minus p. So 1 minus 0.01. So naturally that is equal to 0.99. So 0.99 to the power, yes please, 5 minus 1 that is equal to 4, right? Power 4. Use your calculator and whatever the numbers you are getting, here it is 0.0096, of course, and that is the probability. That is the probability. Because we went over these type of things, I would like to go over one more example too. But before that, I would just provide you what we mean by the mean and the variance for the geometric distribution. So mean and the variance for geometric distribution, mean and variance. So mean mu is given by 1 over p for the geometric distribution, and the variance sigma square that is given by 1 minus p over p square. 1 minus p over p square. I think in chapter 6 or like this, we will be having complete chart, complete table of all the different distributions and its mean